This next section is about tangent lines to circles. By the end of this lesson, I want you to understand a couple of properties of tangent lines so that you can use those properties to solve problems. The first thing you need from previous units is the definition of perpendicular. And perpendicular, if you have two line segments that are perpendicular, that means that they make right angles. So if you see that two line segments are perpendicular, you know that they cross and they make right angles at the point where they cross. And then the other thing that's useful in this section is remembering the Pythagorean theorem. Remembering that when you use Pythagorean theorem, you're going to set the hypotenuse as c, and it's going to be a squared plus b squared equals c squared. A and B are the two legs of a right triangle. So first of all, definition. What is a tangent line to a circle? A tangent line to a circle is a line that touches the circle at a single point or intersects the circle at a single point. In order to be tangent to the circle, the line has to touch at a single point and have just the right slope so that it doesn't accidentally cross again. So that would be the tangent line to the circle. It only touches one time. A word of warning is that you see the word tangent, but it doesn't mean SOHCAHTOA tangent. It's the same word. It's there because of some right angles that are formed, but it's not there as in SOHCAHTOA. The first property of tangent lines is this perpendicular tangent line theorem. It says it has the same format as most theorems, if then. If a line is tangent to a circle, so here's a line, here's a circle, touches at a single point, then it is perpendicular to the radius. So that means it makes right angles with the radius. That's going to be useful because we can use Pythagorean theorem whenever we see a right triangle. The second property that I want you to know is the two-tangent theorem. It's again in the same format of if, then. And if two tangent line segments connect at the same point outside the circle, then the line segments are congruent. So here's the picture. I have a circle. I have a point outside the circle. I have two tangent lines that connect to that point. And what this theorem tells me is that those two line segments are the same size. Okay. After this short lesson, I had students do board work, and I wanted to talk with them about things that were helpful and harmful as we were doing board work. These were the questions I had students in class do for board work. I would try these. They're in your note sheets as well. And then my work for those questions is here. But please ask me in class if any part of this doesn't make sense. I wouldn't expect you to be able to do these problems without an explanation. Just so you know too, the ones that are written in brown are using that perpendicular property for tangent lines, and the ones that are written in black are using the perpendicular property, and the ones that are written in brown are using the congruent property. All right, good luck. Let me know what questions you have. Thank you.